All right, hey everybody, we are back still in predicting results of rigid transformations. I am on slide 13. So we're talking about sequences of transformations. That means more than one thing happening. So maybe it's a reflection and then a rotation off of that reflection. Or maybe it's a translation and then a rotation. Uh, or even a reflection. It could be any combination of the three. Um, so as you can see in question number 1, it looks like we're going to do a rotation, reflection, then a translation. Question number 2 looks like a reflection and then a translation. Question number 3 looks like it's a translation and then a different translation. But I want you to notice as we go through, none of them are dilations. None of them are dilations because remember, a dilation is not a rigid motion. Only translations, reflections, and rotations. So we're not going to see a dilation in this sequence because it's not considered to be a rigid motion. All right, well, let's get into it. Let's see what we got here. All right, okay, so we got some, got a bunch of figures here. Let's see if I can, looks like that's it. So we got 5 different figures going on. All right, so let's see. Locate quadrilateral ABCD and the quad EFGH on the coordinate plane. Use GeoGebra to identify the transformations that will map ABCD onto EFGH and then describe them in the table. Enter the coordinates of the vertices and images that you created. Paste the screen. Capture the images below in the table. Okay, so I'm trying to get ABCD to map to EFGH. Well, map means basically lay on top of. I'm trying to get it to lay on top of it. So you visual people, here is ABCD, and here is EFGH. I'm trying to make this one, the pre-image original, lay on top of the image, which is the new figure. So I'm trying to get this one to lay on top of EFGH. Okay. All right, so it says a rotation of 90 degrees counterclockwise about the origin. Well, if you are a visual person, I'm going to show it to you. So don't forget there are actual formulas for the 90 degrees rotation counterclockwise. So I'm going to put it both ways, you guys. Rotation 90 counterclockwise. So remember that rotation 90 degrees counterclockwise, the cheat code is negative yx. I'm not sure why I have 2 parentheses. That's an oops. Negative yx. So I can use that cheat code and realize that, okay, well, these 2 ordered pairs are going to switch places, and the y, whichever one that was, which in this case is negative 2, is going to change signs. So that negative 2 is now going to become a positive 2, and the 1 stays a 1. It goes to the back. So this is the cheat code. So negative 1 becomes a positive 1. 3 goes to the back. The 4 becomes a positive 4. The 2 goes to the back. And that negative 3 becomes a positive 3. The 1 goes to the back. So there's your cheat code. But not everybody in this class is, a cheat code person. Now, this is what you need to memorize for the ACT, to be honest with you. You're not going to have GeoGebra on the ACT, and it's not going to be any kind of visual representation of anything on the ACT. So if they ask you a rotation 90 degrees counterclockwise, you got to be able to do that on your own. And there's your cheat code for it. Okay, so I understand some of you guys are visual. And you know what? We're just learning this, so I get it. So we're going to rotate 90 degrees counterclockwise, the original figure. So I'm going to come up here. I'm going to do rotation. So it's going to be this figure rotating around the origin. Oh, I got to have a dot for the origin. I don't have one. So let me put a point there. All right, so now I'm going to rotate the figure around the origin 90 degrees, and it's already on counterclockwise. The reason why they keep it on a counterclockwise, you guys, is because that's the norm. If they do not specify on the ACT, they are talking counterclockwise. All right, so there's my figure. So I've rotated it 90 degrees counterclockwise. So there is the first. And you can see that, A prime is 2, 1. And that's what I have. B prime is 1, 3. And that's what I have. C prime over here is the ordered pair 4, 2. And that's what I have. And of course, D prime right here, that's the ordered pair over 3, up 1. So it's going to be 3, 1. So whether you use the cheat code or you use GeoGebra, there's the first move. All right, now we've got to take this figure, not the original, this figure, you visual people, this figure right here, the one we manipulated, and we are going to reflect it across the y-axis. Well, the cheat code for a reflection across the y-axis is you change the x value. So a reflection across the y-axis, you change the x value. So that 2 right there is now going to become a negative 2. 1 stays the same. Okay, that 1 is going to become a negative 1. 3 stays the same. 4 becomes a negative 4. 2 stays the same. 3 becomes a negative 3. 1 stays the same. Well, if you haven't really realized, that's just these flipped around. And remember, when you are switching those two, there is a cheat code specifically for that. So when you switch those two, that's the reflection across the line y equals x. So I've told you guys this before, but it's kind of hitting home. If you do sometimes a series, it ends up being something else all along. So this series ends up being a reflection across the line y equals x, which, that's pretty cool. But not everybody is a cheat code person, so I've got to take this new figure reflected across the y-axis. So this is the one I'm going to reflect across the y-axis. So I'm going to go up to reflect across the line, pick my figure, pick the y-axis, and now it's over here. So these same coordinates for A1, B1, C1, D1 are the exact same ones I put in for my cheat code. And you're welcome to check behind me. They are the exact same. All right, third thing we're doing is a translation 3 to the right. Now again, we're not going back to the original. We're not going back to the first. We're going to the one we just did because this is a series. This is a series we're doing, so we're doing them one after the other. Now, translation also has a cheat code. If you have forgotten, translation of 3 right. Well, 3 right, you're changing the x value. In fact, you are adding 3 to x. So it's going to be x plus 3. So whatever your x value is, you're adding 3 to it because you're going 3 to the right. So for you visual people, we're moving this figure 3 over. So I'm moving it to the right, to this way, which means I am increasing the x 3. I'm increasing this x 3. This C, I'm increasing 3 to the right. The B1, I'm increasing 3 to the right to get to F. So the cheat code is whatever this x value is, you add 3 to it. So I'm adding negative 2 plus 3, and that gives me a 1. The y value stays the same. So this negative 1 here, I'm going to add 3, and that's going to be a 2. The 3 stays the same. Negative 4, I'm adding 3, which ends up being a negative 1. The 2 stays the same. Again, I'm just using cheat codes here, you guys. This is the fastest way to do it. You really want to do this on the ACT. Negative 3 plus 3 is 0, and the 1 stays the same. All right, so not everybody's a visual person, so I'm looking to get these ordered pairs. I'm going to translate it 3 to the right. So I need to go to translation by vector, pick this figure, and I'm going to select A and move a vector to E. So it actually moves it over. You can see it's a little darker. So these ordered pairs are the same as these that I did for my cheat code. So if you need to check it, looks like H is over 0 up 1, and I've got over 0 up 1. Looks like E is 1, 1, and I've got 1, 1 for my A prime. So you guys are welcome to check behind me. Cheat codes are the fast way, but some people are visual until you can remember those cheat codes, and that's fine too. All right, let's see what we've got next. I just submitted number 1. And there's our answers, and of course they show you. There's your rotation, your reflections, number 2, and then translations, number 3. Okay, so they want us to relaunch here. Looks like they want us to relaunch so we can do something different. All right, so it says relaunch transformation sequences. So let me relaunch that. Probably going to be the same screen, just blank. We didn't do anything. Okay, move that out just a tad bit. There we go. All right, so let's see. Locate quadrilateral ABCD and quadrilateral KLMN on the coordinate plane. So this is our original. KLMN is down here. So it looks like I'm probably going to have to map the original ABCD to KLMN. That would be my prediction. All right, use the algebra to identify the transformation that will map ABCD into KLMN and then describe them in the table. Well, the nice thing is they give it to us in the table. All right, so let's see. It looks like I'm going to do a reflection across the y-axis first to the original, and then I'm going to do translation 2 down. And I got to get the coordinates. All right. Okay, so let's see. The first is the reflection across the y-axis. So if you're doing a cheat code, reflection, sorry about that, reflection of y-axis, and I can't apparently type today. You're going to change the x value. So the cheat code is to change the x when you're flipped across the y-axis. So our x's are the 1, the 3, the 2, the 1. All of those are going to change signs, and now they're going to become negative. The y value stays the same. So 3 becomes negative 3, negative 1 stays the same. 2 becomes negative 2, the negative 4 stays the same. The 1 becomes a negative 1, the negative 3 stays the same. But not everybody is a visual person, so we're going to take our ABCD. We're going to reflect it across the y-axis. All right, so I need to go to reflection across the line. My original figure, I have clicked it. I'm going to click the y-axis, and you can see it just flipped it over. So this A prime, B prime, C prime, D prime, these are the exact coordinates that I just put in using the cheat code. So if you need to pause the video and get that, that's cool. I'm going to go ahead and move on because now I've got to translate 2 down. Now I'm not translating the original figure, I'm translating the reflected one. All right, so translation of 2 down. So I don't know if you remember, but the cheat code is when you're moving down, you're changing the y value. So you're going to take the y value and you're going to subtract 2. You're subtracting because you're going in a downward motion. So x is going to stay the same from the new figure, and then our final image, you're going to subtract 2 to all the y values. So x is going to stay the same, but negative 2 minus 2 is a negative 4. Negative 3 is going to stay the same, but negative 1 minus 2 is a negative 3. Negative 2 stays the same. Negative 4 minus 2 is a negative 6. Negative 1 stays the same. Negative 3 minus 2 is a negative 5. So there's going to be our final figure. That's called the final image. That's going to be almost like a double prime, or they'll probably call it A1, B1, C1, D1. But let's go ahead and do that for my visual people. I'm translating it 2 down. This figure right here, the one that was reflected. So I've got to translate by vector. And I'm going to pick this figure. And it doesn't really matter which one you do. I'm going to do B to L. And then you see it moves it down and makes it a little bit darker. So it lays right on top of. That means it maps to that final figure. All right, you guys. So if you're a visual person, there you go. We reflected. We translated down 2. If you are wanting your cheat codes, there they are. And you can hit submit. It's going to give you the figure below it. as a sample answer. So there you go. Reflection across the y-axis, translate 2 down. All right, let's let them give us another one. So example number 3 or question number 3, we're going to relaunch transformation sequence. Excuse me. Looks like we got the same figure. Out just a tad bit. All right, so we're locating quadrilateral ABCD and quadrilateral PQRS. So there's my original. PQRS is right here. So I predict we're going to map our original to the image in some form or another. All right, so we're going to use GeoGebra to identify the transformation. Of course, they tell us what it is. We're going to map 5 units up and then translate 5 up and then translate 3 to the right. So it's just a double translation. Okay, no problem. Cheat code for translation of 5 up. Well, if 5 up is the change in the y, you are going to go up 5. So the x stays the same. The y value, because you're going up, you will add 5. So we're going to add 5 to every y value. So if you're doing a cheat code, this x is going to stay the same. -2 plus 5 is 3. The next one, 3 stays the same. -1 plus 5 is 4. Alrighty, so let's see, this 2 stays the same. -4 plus 5 is 1. 1 stays the same. -3 plus 5, that is a 2. Alright, my visual people. So we are translating the original 5 up. So we got to do a translation by vector. Translation by vector. I'm going to pick my original figure. I'm going to select B, 1, 2, 3, 4, and 5. So it moves it up 5. So all of these order pairs, A, B, C, D, will be the exact same as my cheat codes. And now I've got to take this image figure and translate it 3 to the right. All right, so there's a cheat code for that, translating 3 to the right. Well, for you visual people, we're moving it over this way, so I'm changing the x value because I'm kind of running parallel to the x-axis. And I'm going to the right, so it's going to be a positive change. So you're going to take x and you're going to add 3 because we're going 3 to the right. So every single y here is going to stay the same, but this x value, this 1, this 3, this 2, this 1, you're going to add 3 to them. So 1 plus 3 is 4. The 3 stays the same. 3 plus 3 is 6. The 4 stays the same. 2 plus 3 is 5. The 1 stays the same. And the 1 plus 3 is 4. This -3 is going to stay the same. All right, visual people, we're going to translate this image to the final image 3 to the right. So we're going to take this figure. We're going to translate by vector. I'm just going to pick C because it's easy to get to. Or you can pick this one up here. So I'm going to pick C to R, and then it lands right on top of it. So I've gone translate 5 up. I translated 3 to the right. So these coordinates for this final image are the same coordinates that I did for cheat codes. Completely up to you how you want to do this. Cheat codes or if you're a visual person. But remember, you're not going to have a visual representation on the ACT, so you pretty much want to learn these cheat codes because it's on the ACT, and you want to be able to do these problems in, 15 seconds or less because you only got 1 minute per problem. All right, there it is. Up 5, right 3. Okay. Relaunch transformation sequences. Question number 4. Locate ABCD in quadrilateral TUVW. Well, they don't give me an option to launch it, so I guess I got to go back to one of these and just undo until I get back to my original figure. All right, so undid everything. Move this. All right, so I'm going from ABCD to TUVW. So ABCD to TUVW. So I'm going way up here. Oh, okay, they give us 3 things to do. All right, we're going to take it one at a time, you guys, the cheat codes, and I'll do the visual representation of that as we go. Okay, so let's see. The first one is reflection across the y-axis. All right, so what's the cheat code for that? You are going to change the x value. All right, so all of our x's, this 1 is going to become negative, 3 become negative, 2 becomes negative, 1 becomes negative. The y's stay the same. -1, -2. -3, -1. -2, -4. And 1 becomes -1, -3 stays. All right, so we're going to do a reflection. Let me change that. I can't spell reflection apparently. There we go, reflection across the y-axis. So you visual people, we are taking this figure, reflection across the y-axis, so I got to reflect across the line. The original figure, y-axis. So these ordered pairs are the same I did for that first move in this series. All right, second one is translating 2 down. Well, that's interesting. If I'm trying to get up here, why would I translate 2 down? I'm not sure, but I'll end up landing on top of this one. So let's see what's going on. Well, I'm not sure why they were asking me to do that, but let's figure it out. So translation 2 down. Remember, you're going down, so you're changing the y. So you're going to take y, and you're going to subtract. Oh, I'm sorry, I put a t. Y subtract 2. So all the x's will stay the same, but all of these y's right here, this -2, -1, -4, -3, you're all going to subtract 2 on each one because we're translating. So -1 stays the same. -2 minus 2 is a -4. -3 stays the same. -1 minus 2 is a -3. -2 stays the same. -4 minus 2 is a -6. -1 stays the same. -3 minus 2 is a -5. All right, so visual people, I'm going to translate by vector 2 down. So this is the one that I've got to pick. So translation by vector. Pick your figure. I'm going to move it 2 down. All right, so there is my second image in the series. And these ordered pairs for the one that's highlighted are the ones that I just did. Third and last in the series is a reflection across the x-axis. All right, cheat code is you change the y value. So reflection across the x-axis, you change the y value. What I mean by that is you change the sign. So the -4 changes to positive. -3 changes to positive. -6 changes to positive. -5 changes to positive. I like reflections. They are easy. So -1, +4. -3, +3. -2, +6. And -1, +5. All right, my visual people, we're going to take that and reflect it across the x-axis. So now I know why we moved it down 2, because we're going to reflect across the x-axis, and this sucker is going to land right on top of the UVWT. All right, so we're going to do a reflection about a line. Pick the last image you did and the x-axis, and then it flips over and bam, lands right on top of UVWT. So these coordinates right here are going to be the exact same as my predicted coordinates using my cheat codes. So I am good. You hit submit. All right, there it is. You guys, we did a reflection 1, translation 2, and then reflection 3. Oh my goodness, question number 5. Is this the last one? Yes, thank goodness. Okay, so there are usually more than one sequence of transformations that can produce an image from a given pre-image. Now you will describe a sequence of transformations that is different from any sequence observed in question 1 through question 4. Read launch transformation sequences. Okay, so we got the exact same figure. Move that out just a tad. Locate the quadrilaterals ABCD and TUVW. Well, that was the one we just did. ABCD. All right, TUVW. That's the one we just talked about in question number 4. Use the GeoGebra to identify the transformations that will map ABC to TUVW and then describe them in the table. Oh, okay, I see what they're saying. So in question number 4, they did it in 3 moves. In question number 5, they're saying we can do it in 2 moves and still be the same mapping. Oh, okay, I got you. That makes sense. I said that earlier, in that some things happen to be the same things. It lands back on top of one another. Okay, so that's what they're saying here, is that we can do the same thing in 2 moves instead of 3 moves. All right, so, okay, no problem. So the first thing they do is to do a clockwise rotation of 180 degrees. So there's a cheat code for that. 180 clockwise. Well, on 180 counterclockwise and on 180 clockwise are really just the same thing. The cheat code is you change the sign of X. You also change the sign of Y. So there's our first cheat code. We're going to take our original figure and we're going to change the signs of both of the numbers. Now don't worry, you visual people, I am going to show you how to do this. But this 1's going to become -1, and that -2 becomes a +2. So we're changing the signs of both. 3 becomes -3, 1 becomes +1. Changing the signs of both. 2 becomes -2, -4 becomes +4, and then 1 becomes -1, -3 becomes +3. All right, there's your cheat code. Now let's do this on GeoGebra for my visual people. So we're going to rotate clockwise 180. Well, actually clockwise of a 180 and a counterclockwise of a 180 are the same thing. Also, just kind of a quick tip, a double reflection can also be a rotation of 180. Okay, so we're going to take our original figure and do a rotation. Okay, I've got to have a point there to rotate it around. So I'm going to give myself a point of rotation at the origin. Now I'm going to click rotate around a point. Click my original figure and the point I want to rotate around. They want it to be 180. Not that it really matters on a 180, but I am going to click clockwise because that's what they say to do. I'm going to hit OK. So there it is. Clockwise, whoop, boom, there it is. So this ABCD is the same coordinates of me doing a cheat code. Okay, next thing, so I got to translate 2 up. Translation 2 up. All right, sorry about that. All right, so if I'm moving up, you guys, you visual people, I'm changing the Y value because the Y is the one that moves up and down. And because I'm moving up, I'm going to add the number to whatever Y is. So I'm adding 2 to all the Y values. So this X, that's the -1, it's going to stay the same. 2 plus 2 is 4. This -3 is going to stay the same. 1 plus 2 is 3. This -2 is going to stay the same. 4 plus 2 is 6. And this -1 is going to stay the same. We're going to add 3 plus 2, and that makes 5. All right, so there it is. We're done. Now, my visual people, we're going to translate that 2 up by vector. So we're going to do translation by vector. Pick your image. And I'm just going to do this one. It's the easiest one. Translate it up 2, and it just moves it into place. So you guys can see, after you submit, that what we did in question number 4, we reflected, translated, reflected, can be done in 2 just by doing a rotation and then a translation. So sometimes it's easier just to do 2 moves than it is to do 3 moves. But not everybody sees this the same way, you guys. Not everybody's going to see it the same way, so you got to kind of, well, for me, learn how to teach in different ways. I do these little cheat codes for the ACT and for people that can or prefer to do little formulas. And of course, I'm a very visual person, so I've gotten kind of good at visually seeing what's going to happen in your GeoGebra. All right, you guys, so if you are looking at this video and you are like, oh my goodness, Miss Eccles, I'm so lost, watch it again, send me a message. I don't mind helping you guys, but I'm hoping this video is helping you guys do this right way. All right, you guys, so that is a series of rigid motions, and probably one of the hardest things we do in here is because you've really got to pay attention. You got to know those cheat codes. All right, you guys, so that's the end of Unit 1. You guys are getting ready right now for your post-test. So if you've been keeping up with your notes you've been taking in class, or if you need to keep your GeoGebra open, because I've been telling you guys how to cheat as we go, yeah, good luck on your post-test, you guys. All right, see you later.